Okay, for those who just join the Google Meet, okay, please click the link and also enter the code that I gave. Or you can just scan the QR code here. Okay, so please join the class point. Okay, so only 6 people just join now. So where are the rest? Are you having a problem? You cannot join the class point? Whereas 25 more. Please join. Teacher, I can join the class. Why? Okay. Maybe I will try to generate a new one. Okay, wait for a while. Hmm. Wait. I create a new code for you, right? Okay, so let's try to make a new code. Okay. Okay, try to change to this code. Is it the same? Is it still the same? Oh, really? Same. All right. They said they're having, I tried to open again, right? So this is the last. If not, we just continue, okay? This is the last try. Okay, wait for a moment. We are on diffraction, right? Okay. Mm, okay. So yeah. Still can. Yeah. Same as me also. I also try to using my phone. Okay. Still it's not working. So never mind. Okay, so we just continue. Okay. I think we are on the question part, right? We are already on the question part. I think this one. Okay, so what you have to do, you just give an answer in the chat, all right? So let's try to answer for question tutorial 6.5, okay? So for number 1, okay? So try to answer this one first. C. So it says which of the diagram below shows the water wave, okay, which passes through a small gap correctly, right? So the answer should be C. Okay. Oh. Good. Now my slide also hang. Okay, so the answer is C. Okay, for the next one, okay, yeah. Diagram 7 shows a water passing a block of rock in a river. So which phenomenon explain the propagation of water at X? So what happened at the X? What happened at X here? C. Yeah. So this one is actually the diffraction. So this is like an obstacle, okay, and the water wave pass through it. Okay, so the answer is C. Before that, can monitor please take the attendance who is still not here? Okay, so this one for question 4, right? So it says here diagram 4.1 shows the pattern form when seen through the gap of two fingers. So name the light phenomenon involved. So this one we call it as a diffraction because the light passes through the gap that between the two fingers. Okay, so in the space provided above, so draw the pattern form when the gap size between the two fingers is decreased. Okay, so this one is like a diffraction of light. Okay, so what happen if we make the slit smaller. Okay, so what happened here? Okay, so what happened to the bright fringes? Okay, here is it become small, okay, or become bigger? Is it the middle here, the bright fringes in the middle here, it becomes smaller or it become bigger? Okay, what happened here? Okay, diffraction of light, right? Okay, so here what it said, a single white slit, okay? So very bright light in the middle, okay, while single narrow slit, dark and bright lines are alternately brighter in the middle. So as you can see, when you increase the size of the slit, okay, so in the middle they become the smaller, right? The bright fringes here at the middle here, it become smaller in size, okay? So here you can see it increased the size of the slit, okay? And you can see here the bright fringes on the middle, okay? It becomes smaller when the size of slit is increased. So what you have to draw here, okay? So what you have to draw here is, okay? So you just draw the same thing, but in the middle here, okay? The bright fringes will become smaller. Okay, so this one you have to color it. Okay, so it can become darker here. So this is to show that it's a dark fringes. Okay, this one is the dark, bright, dark. Okay, thank you. Okay, this one also dark. Okay, but in the middle, the bright fringes, okay, the size of it become smaller. Okay, since the slit is increasing, the size of the slit is increasing. Okay, so it will become like this. Okay, bright. Okay. Okay, so the size here is become smaller. Okay, the next one. Okay, so this one you have to answer. So B3 and C. Okay, explain why the phenomenon, okay, in 4A is more difficult to be observed with light compared to the sound wave. Okay, so this one we already mentioned. Okay, in the class 2 weeks ago, I think. Okay, why does it why the wave diffraction, okay, is hard to be observed if you're using the light wave, okay, if you're using the sound wave. Wait for a moment, I try again to scan. Maybe it's already okay now. Okay. Okay, you can give the answer. Just type B3, what is your answer? C, what is your answer? Okay, so what's your answer for B2? What happened to the amplitude of the light after it passed through the gap? So we already know for diffraction, okay, before the wave is being diffract, okay, before and after, okay, before and after the speed, okay, the wavelength and the frequency is same, okay, but the only thing change is the amplitude. Okay, so the amplitude, what happened to the amplitude? Okay, whether it's decreased or whether it's increased, and also the amplitude is represent the energy. Okay, representing the energy. So what happened here? Okay, and see why it's hard to observe, okay, the diffraction of light, okay, compared to the diffraction of sound wave. So you have to see the two factors that affect the diffraction of wave. Okay, the first one is the size of slit, right? So the smaller the size of slit, okay, the effect of diffraction, okay, will become more obvious, right? But it say if you for the and then the second one is the wavelength, okay. So what happen if we increase the wavelength? So what will happen to the effect of diffraction? Okay, I give you like 2 more minutes to answer. Nine, eight, six, eight, six. Yeah. So anyone want to try for this one? What will happen to the amplitude? The amplitude is decreased. Okay, good. Kenzing. Yes, the amplitude is increasing. Sorry, decreasing. Okay, the amplitude is decreasing. Okay, and then why does the diffraction, right? Diffraction in light wave, okay, is hard to observe. Okay, if you compare with the sound wave. So what is the difference between the light wave and the sound wave? So what is the difference between these two waves? Anyone want to try? What is the difference between these two waves? Okay, remember I said this a diffraction of light, diffraction of sound. Okay. So the difference between the sound actually and the light, okay, is because of the wavelength. Okay. So the wavelength of the sound wave is higher than uh, the wavelength of the sound wave is higher than the light wave. Okay, so that's why it's hard for the light wave. Okay, for the light wave to be diffract. Okay, and compared to the sound wave. Okay, so we already know. Okay, there are two factors that affecting the diffraction. The first one is the size of slit. Okay, so if the smaller the size of slit, smaller size of slit, okay, so it will increase the effect of the diffraction. So if let's say if for the water wave, it become the wave will become more circular like that. Okay, more circular. Okay, but let's say the next one, the second factor is the wavelength. Okay, so if you use the higher wavelength, okay, you increase the wavelength here, the effect of the diffraction also will increase. Okay, so in this case, we use the sound wave. So sound wave, it has a high wavelength compared to the sound wave. Okay, so means it is better for it to diffract, okay, then if we compare with the light wave. So here you just said sound wave have higher wavelength, okay, have higher wavelength, okay. So the effect of diffraction is more obvious. Okay, so because the higher the wavelength, the higher the effect of diffraction. So means it's easy for the sound wave to be diffract because of the wavelength is higher. So that's the answer. Okay, so how about this one? Okay, so this one you have to compare. So what does it mean by diffraction? So what does it mean by diffraction? What does it mean by diffraction? And this one you have to mark and label the wavelength. Okay. So I give you the label here. Let's say this is A, this is B, and this is C, and this is D. So you can just use the words, okay? You can use the letter there, okay, to represent the wavelength. Diffraction is the spreading of wave when the wave propagates through a slit or side of the barrier. Okay, correct. Okay, Alicia's. The spreading of wave around obstacle. Okay, so but I think the more accurate one is the Alex answer, right? So diffraction is spreading of wave when the wave propagates through a slit or side of the barrier. So it's a spreading of wave when the wave enter the slit or pass through the barrier. Okay, so that's the answer for the diffraction. Okay, so the wave will be spread, okay, and also at the same time the energy also will be spread. Okay, so for B, so you have to mark and label the wavelength with lambda. So which one represent 1 lambda? So which one represent 1 lambda? Okay, so this one already showed the answer. BC, AB also represent 1 lambda. CD also represent 1 lambda. Okay. Okay, the next one you have to compare the wavelength. So compare the wavelength and also compare the shape of the diffracted sound wave. So which one have the higher wavelength? Okay. And how about the shape of the diffracted sound wave? Okay. Is it which one is more circular? A is higher than B. Okay, so you compare the wavelength, okay, 5 to A, okay. So 5 to A, the wavelength is higher. So you can use the symbol here, 5.2 okay, but you have to put the wavelength like this. So wavelength 4.2A is higher than 5.2B. Okay, and how about the shape? Okay, so which one is the more circular? So diagram 5.2. Okay, this one you have to put the words. Okay, so diagram 5.2 A. Okay, the wavelength is more circular. Okay, than 5.2B. Okay, so that's the answer. Okay, so you have to know if the water wave, okay, is more diffracted, okay, so means it will produce the wavelength will become more circular. Okay, means it will be more diffracted. Okay, what happened to the amplitude of the diffracted? Okay, and you have to explain your answer. And what is the relationship between the wavelength and the amplitude of the diffracted wave? Okay, what happened to the amplitude? Okay, just now we already answered. What happened to the amplitude? What happened to the amplitude? And why does that happen? So what the answer? What will happen to the amplitude? So the amplitude will decrease, right? So good, Junkiat. Okay, it will decrease. Okay, so good answer. So what happened to the amplitude? So the amplitude will decrease. Okay, the amplitude will decrease. So explain your answer. So just now I said the amplitude is actually represent the energy, right? So when the water wave pass through the slit, all right, so the wave will be spreading. Okay, the wave will be spread out like that, and at the same time, the energy also will be spread out. So means that's why the amplitude decrease, because of the energy also decrease. Why it decrease? Because the energy is spreading out, okay, to all the area. Okay, so here you can say the cause of the energy is decreasing. Okay, the energy is spreading out. Okay, when the wave, right, when the wave, okay, pass through a slit. Okay, so the energy is spreading out when the wave pass through the slit. Okay, and then you have to state the relationship. So remember, there are two factors that affect the diffraction. The first one is the size of the slit. Smaller size of the slit will increase the effect of the diffraction. And the second one is the wavelength. If you use the higher wavelength, okay, the amplitude of diffracted wave also will be increasing. Okay, so that's the answer. The effect of the diffraction increase means the amplitude is decreased. Okay, the longer the wavelength, okay, the smaller the amplitude, means the energy will become smaller, because it means the energy is spreading out more. Of diffracted wave. Okay, so that's the answer. Okay, so we already finished diffraction. Okay, now we move on to the interference. So this is the last phenomenon. We already learned refraction, reflection, okay, diffraction, and this one is the last one, interference of wave. Okay, so diagram 1.5.1 shows a water wave when two stones are thrown in the water. So what happens if this water, if the wave overlap? Okay, so this is actually to generate the idea what is actually the interference. So the interference occur when there are two waves. Okay, when there are two waves, okay, they overlap with each other. So that will produce the interference. Okay, so this is actually the interference. Yeah, this is not. Yeah, this is the video. So you see there are two sources vibrating here. Okay, and the wave, okay, produced by these two sources, okay, they will overlap with each other. So you can see there will be overlap with each other. So this one we call it as the interference. Okay, interference.
Hi, it's Mr. Anderson, and this is AP Physics Essentials video 113. It's on wave superposition. What does that mean? When waves interact with each other, they can either build each other up or tear each other down. And so let's watch this wave right here. We're sending two waves. These are transverse waves towards each other.
Okay, so means there are two sources of wave. The first one come from the left, okay, and the other one come from the right. Okay, so this is a transverse wave. So what happen if these two wave, okay, they overlap each other? Okay, so what happened here? Let's see.
And so what's going to happen when they meet? What's going to happen at that point where the slinkies are connected? Well, there will be superposition. They'll come together, and we're going to add the values that they had before. And so watch what happens when they come together. We get one giant wave.
Okay, so you can see when there are two waves come from the left and come from the right, okay, and then when they meet with each other, you can see they produce the high amplitude there, right? The high giant wave there. Okay, so means there is a, this is called, we call it as a superposition. Okay, when there are two waves met, okay, and then when they meet, when they overlap with each other, they will produce the high giant wave. Okay, this one is actually a constructive interference. Okay.
Now it's hard to watch that and figure out, did the waves hit each other and bounce off, or did they go through each other? So this one might help a little bit. We've now got a wave coming from the left that's on the top and from the right.
Okay, so this one, when the crest, okay, still same. Okay, just now is crest meet crest, right? So when the crest meet crest, they will produce a high giant wave like that. Okay, the amplitude is higher. Okay, you can see the amplitude produced there is higher when there are two waves. Okay, there is a one from crest and crest. Okay, but for this one, it comes from the, on the left side here is crest, but at this side is a throw. Okay, so let's see what happened, okay, when they overlap with each other.
That's on the bottom. And so what's going to happen here? Well, you've probably figured out that they'll cancel each other out. And so if you watch that point in the middle, it won't move up or down very much at all. But watch what happens to those waves after they hit. The one on the bottom continues to the left on the bottom, and the one on the right continues on the right.
Okay, so mean after they overlap with each other, okay, after they overlap with each other, okay, so at this point it become like it doesn't move at all, but the wave is going back, okay, to its original position. Mean it's like being reflected back. Okay, so this one we move back to here, and this one we move back, okay, to the right. Okay, so this is called as the superposition.
Bottom continues to the left on the bottom, and the one on the right continues on the right. And so when waves interact, they don't bounce off each other. They will move right through each other. But as they move through each other, they will interfere with one another. And that interference can be constructive. In other words, when two waves come at each other, we build one giant wave. Or it can be destructive. In other words, they cancel each other out. But superposition is that idea that when they're together, we add those two values together. Giant wave. In other words, when two interference can be constructive.
Okay, so just now there are two waves that interact with each other. So at the point when they overlap with each other, we call it as the interference. Okay, so just now, like when the wave come from the left. Okay, so let's see the video again. Okay, so this one come from the left is the crest also. This one is come from the right also is the crest. So when a crest meet a crest, okay, so you can see that
add the values that they had before. And so watch what happens when they come.
Okay, so you can see here, wait for a moment, sorry.
These are transverse waves towards each other. And so what's going to happen when they meet? What's going to happen at that point where the slinkies are connected? Well, there will be superposition. They'll come together, and we're going to add the values that they had before. And so watch what happens when they...
Okay, so here you can see they produce the high giant wave like that. Okay, so the crest become higher. Okay, so this we call it as a superposition. Okay, so that is what happened when the crest meet the crest. Okay, so and this one we call it as the constructive interference. Okay, there are two types of the interference, constructive and destructive. So this one is the constructive. Okay, and another one is when the crest meet the throw.
Here, well,
okay, so
out
this is come from the crest, from the left is crest, and from the right is throw. So what happened at the middle here?
Watch what happens to those waves after they hit. The one on the bottom continues.
Okay, so here they produce like zero. Okay, they didn't move at all, but the wave we continue back moving to the right, and another one we continue moving to the left. Okay, so this one we call it as a destructive. Okay, when the crest meet the throw. Okay, so this one we call it as a destructive. So the amplitude at the center there is zero. Okay, so it's like they cancel out each other. Okay, so there are two types of interference, constructive and also destructive.
Longitudinal wave from the right. And so watch what happens is that they move right through each other. And so if I take a picture of right when they're together, what we're doing is simply adding wave A plus wave B. It's very simple. It's almost like algebra as a way to think about what happens to the waves. And so if we have two waves that are in phase like this, and so let's add numbers to it. Let's say this wave here is 1 centimeter above equilibrium, and this is 1 centimeter above equilibrium. Then what's going to be the constructive wave of those two together? Well, it's simply going to be, let's add them up, it's going to be 2 centimeters above. Or right here, it's at 0, at here it's 0, so here it's also.
Okay, so I will explain about this one. All right, so let's say when the crest meet the crest, okay? So this is a constructive interference, okay? So when the crest meet the crest, so let's say the amplitude here is A, okay? And this one also, the amplitude is A. So what happened here, okay, at the middle here, where the point they meet each other, okay, they overlap with each other, okay, there will produce the energy, or they will produce the wave, okay, that have the amplitude 2A. Okay, so this is the constructive interference. Or let's say throw meet with throw. Okay, so this one they say negative A. Okay, this one is a negative A. So what they will produce negative 2A here. Okay, they just use the simple algebra here. Okay, so this is, we still call it as a constructive. Okay, then this one is actually, we use the concept of superposition. Okay, we use the concept of superposition. Okay, and another one is a destructive. Okay, destructive interference. So this one, when the crest meet with the throw. So this is A, okay, and the throw is a negative A. So what happened here? So A plus negative A, you will get A minus A. So means this one is 0. So destructive interference, they will produce 0. Means the energy will become this one, like this. Only a straight line like that. Okay. So this is the destructive interference. So let's say if I changed it, let's say I change the letter to a number. I have 1 cm of amplitude. Okay, and this one is also 1 cm of amplitude. So what happened here? The amplitude will become 2 cm. Okay, when the interference occur, so that one will become 2 cm. But for this one, let's say I have negative 1 cm here, negative 1 cm here. So I will get negative 2 cm. Okay, but for destructive, let's say this one is a positive, this one is 2 cm. And this one is negative 2 cm. So 2 cm plus negative 2 cm. So you will get 0. Okay. So this is actually the interference. When the wave, okay, when the wave, two source of wave, okay, they overlap with each other. Okay, so that is, we call it as the interference. Okay, so this one, they use a slinky spring. Okay, just like the video we see just now. Okay, so the one come from the right, and another one come from the left. Okay, so they will meet at the center of it, right? So at the moment they meet, okay, they overlap with each other. So that time, okay, the superposition, okay, we use a concept of superposition to explain, okay, the interference wave that occur, okay, at the center of the slinky spring. Okay, so there we overlap. Okay, so when the two pulses met, okay, so they produce the high giant wave. Okay, okay, so there we overlap. Okay, and then there we go move, okay, back to the original direction. So they will move, this one they will move to the left, and this one they will continue to move to the right. Okay, so here after that, after they overlap with each other, okay, the red one will just continue move to the left, and the blue one will just continue to the right. Okay.
Tak masuk dalam video ni. Tiga ni. Satu, dua, tiga. Oh, cantik ya. Ini. Tiga.
So you can see they produce the high giant wave, okay, in the middle here. Okay, so that is the interference. Okay, and after that you have to compare the amplitude of the wave after they met with the amplitude of the single wave, okay, before both wave pulses met. So you have to compare the amplitude. Of course, when they met is higher because you already know, okay, this one is the original one. Okay, let's say this one is A, okay, it come from the left. Okay, and this one also A, the amplitude is A, okay, and it come from the right. So at the middle here, when they met, they will produce 2A, right? So of course here, if we say that after they met is twice time higher. Okay, so this one A plus A, so you got 2A. So that's why it become twice higher. Alright, so write an equation to relate both amplitude of two pulses before they met with the resultant amplitude after they met together. So this one I already teach you A plus A is 2A. Okay, and another one, so A plus A is 2A. Okay, or we can put negative A. This one, let's say for throw. Okay, for throw you get negative 2A. This one, let's say if crest meet crest. Okay, if if throw meet throw, it become negative 2A. Okay, and this one we call it as a constructive interference. Okay, combining two overlapping waves can be explained by principle of superposition. Alright, so when two waves interfered, okay, the resulting displacement of the medium at any location is the algebraic sum of the displacement of the two individual waves. So what does this mean? So when the two waves interfered, okay, so mean when they meet at each other, they overlap with each other. So the result of the displacement, okay, so how you want to find the displacement or the amplitude, okay, you just need to sum the algebraic, okay. So means that just now A plus A. So you will get 2A. So that is the displacement. So this one is the example. A1, A2. Okay, so at the middle when they interfered, okay, when the interference occur, so A3 is actually equals to A1 plus A2. Okay, so when two waves met, they superpose or combine at particular point. Okay, there will be overlap at the particular point. So the waves are said to interfere. So when they meet, okay, they meet or they overlap with each other, we call it the waves are said to be interfered. So this phenomenon is called as the interference. So what does it mean by interference? So interference is actually the superposition of two waves originating from two coherent source. Okay, from the two coherent source. Okay, so this one means, okay, remember, okay, the superposition. Okay, the superposition means when the two wave, okay, the two wave come from the two source. Okay, just now we see the one coming from the left and another one coming from the right. So there are two source, okay, and they combine. Okay, they combine or at the middle there, they will be met with each other, they will overlap with each other. So that one we call it as the interference. Okay, so how do you want to know what is the amplitude, okay, that we produce during the interference? We use the principle of superposition, means you just add up the number of amplitude. So let's say 1 cm. So for 1 cm from the left and 1 cm from the right, the amplitude. So when you add, you got 2 cm. Okay, so the interference is the superposition of two waves originating from two coherent sources. Superposition means you have to plus. Okay, you have to add the two sources amplitude. Okay. Right, so this is for crest meet crest, and this one is throw meet throw. Both is also constructive interference. Okay. Yeah, so this one we call it as a constructive. Okay, if let's say from crest to let's say the superposition is from crest to throw, so you will get 0. Okay, but then after that the wave we continue, the red one, we after the interference occur here, the red arrow will just move back to the left, and this one will move to the right. Okay, so it will just continue to its original direction. This one we call it as the destructive interference. Okay, so what does it mean by coherence? Okay, so the coherence means they have to have the same frequency, same wavelength, and the same phase. Okay, same frequency, same wavelength, and the same phase. So for this one, they say you have two sources. Let's say you have to use two sources, right, to produce the interference. So make sure you use the same frequency. Okay, and the wavelength also must be same. Okay, cannot like this one 6 centimeter, this one 8 centimeter, cannot. So both must have the same wavelength. Okay, so that they can produce the interference. So that's the rule. Okay, if you want the interference to occur. Okay, so the source must be coherent. That one is for water wave. So how about the light? So for interference of light, okay, the coherent, when you say the coherent source, so it means they must have the same color and also the same wavelength. You cannot use the first source, you use a yellow color, okay, yellow light, and the second one you use a red light, cannot. Okay, they must use the same color and the color must have the same wavelength. Then the interference can occur. So that one is for interference of light. But this one for interference of water, make sure when you use the dipper, the dipper will vibrate inside the ripple tag. So both dipper must have the same frequency, okay, for vibration. Then the interference can occur. Okay, so this one is a dipper here. Okay, so it will vibrate. So when it vibrate, okay, you have to setting the frequency there. Okay, so you have to set the same frequency for both source. Okay, for the both dipper. So then you can see the interference. Okay. All right, for interference, there are three ways. Okay, the first one we use a water wave. Okay, and we can see interference also can occur in the light. Okay, and another one also it can occur into the for sound. Okay, sound interference. Okay, so we see for the constructive interference. So constructive interference occur when the crest or throw of both waves, okay, coincide to produce a wave with crest and throw at maximum amplitude. Okay, so it's just said that constructive is the when crest meet crest or throw meet throw, and that will produce the maximum amplitude. So that we mean by the constructive interference. Okay, so you can see they have the same phase, right? Throw meet throw, and the crest meet crest. Okay, so here when they meet here, so the constructive interference at the throw part here, you can see the amplitude here is bigger. So it's twice than here. Okay, so this is like a sum of these two wave. Okay, so this is the throw, this is the throw, so it add, so it become, the amplitude is become twice, okay, higher. And this one also crest meet crest. Okay, so you can see here the amplitude of the wave here become twice than this one. Okay, so it just like sum off of these two wave here. So let's say if I have this one, negative A, so this one, the amplitude will be negative 2A. Okay, so this one, what is the principle that you use? The one that I said, negative A plus negative A, that one is a superposition, principle of superposition. Okay, and this one is a A, and this one also A. Okay, so this one should be 2A. Okay, so this is a constructive interference. So how about the destructive interference. So it occurs when the crest of wave coincide with the throw. Okay, so this is the example. Okay, so you can see this is the throw and this is the crest, right? So this one I have negative A and this one is a positive A. So when I add these two, okay, when I add these two, negative A plus A, then you will get 0. So this is the destructive interference. So it occurs when the throw meet the crest, okay, and they will cancel each other. So as a result, the amplitude is 0, okay. Okay, so for the water, it says here for constructive interference, okay. So the water, the movement of the object. So let's say if I put the object here, okay, let's say I put the ball here. So for the constructive interference, okay, let's say for the constructive interference, if I put the ball at the point that occur the constructive interference, so the ball will move up and down. Okay, but let's say if I put at the destructive interference, okay, I put the ball at the part where the destructive interference occur, the water is calm. So means the object will not move up and down. Okay, it will be like static like that. Okay, this is for the water. Okay, for the light, okay, the constructive interference is produced by, it will produce the bright fringes. Okay, so they will produce the bright fringes. Okay, while the destructive, they will produce the dark fringes. Okay, so that one we see later about the light. Okay, and the sound. Okay, for the sound, for the constructive interference, they will produce the loud sound. Okay, but the destructive interference, okay, for the sound, they will produce the soft sound, okay, or sometimes silent. Okay, so this one you have to know what happened if for the water wave, okay, if the constructive interference occur, what happened to the water. Then they see if I put the object there, what will happen? Will the object move up and down? Okay, if the interference, destructive interference, if I put an object there, the object will not move up and down. Okay, it will be just stay like that. Okay, but for the interference of sound, okay, for the, if the constructive interference occur, they will produce the bright fringes. Okay, this one, the red one. The red one is the bright fringes. Okay, so you know this one, oh, bright. So of this one is interference, is the constructive interference. Okay, while the destructive interference, they produce the dark one. So the dark one is this side. So it's produced the destructive interference. Okay, and another one for interference of sound. Okay, if the loud sound produced mean is constructive interference. If the sound is soft one, okay, they produce the soft sound. So that's mean at that point the destructive interference occur. Okay, and how about the antinode node? Okay, so antinode is actually where the point of the constructive interference occur. Okay, sometimes they say for the light, right? For the light, they use the antinode. Okay, they said antinode occurs. So antinode means you already know that one is the bright fringes. Okay, for the light, is a bright one. The bright fringes. Bright fringes is the antinode. Sometimes they didn't mention about the bright fringes. They just put antinode and node. So you have to know the antinode is the bright fringes, okay, for the light. And it means at that time the constructive interference occur. While the node is actually the dark fringes. Okay, so they will produce the dark fringes here. Okay, so this one means the destructive interference occur. Okay, how about the antinode line? So the antinode is the line which connect all antinode points. Okay, so let's say in the water, they connected all the interference called constructive interference. Okay, they connected all the constructive interference. Okay, where the point that have all the constructive interference, they connected to each other. Okay, while the knot line is the line which connect all knot points. So you already know is actually the destructive interference. So they connect all the point that destructive interference occurs. So then they connected it. They make a line. Okay. Okay, this one is to study the interference pattern of water waves. So again, we use a ripple tank. Okay, so you have to compare the frequency. So the frequency must be same. If not, there will not be coherent. Okay, so if they're not coherent, then the interference of wave will not occur. So what is the name given to the sound which has the same frequency and the same phase? So this one we call it as the coherent. So two coherent source. Wait, I see first whether they can play it or no. This is not a video. Okay, so this one we already see. Okay, I think the first or second slide before. Okay, so this is the two source. You see they vibrate. Okay, they produce this, the wave, and the wave interfere each other. Okay, so you can see there is a part, right? There is a part where the constructive interference occur, like this part. Okay, this part is a constructive. Okay, so later we will see more. Okay, here. Wait for a moment. I have another video, so maybe this one is much clearer for you. Do you have any question to ask about the interference? Okay, do you have any question to ask? For constructive and destructive? Are you clear? Okay. So this one is the...
Basically, this is the setup.
Oh, this
The
one is
camera-
sound wave. Okay, sorry. I want you to see the water wave first. Yang double slit, this is a light. Yeah, this one. Okay. So this one is much clear. Okay. So this is actually we do this experiment in the ripple tank. Okay. So there are two sources here vibrating. Okay. So they're deep in the water. Okay. At the same frequency. All right. So here you can see the bright, right? So remember the bright one is actually the crest. Okay. And the dark one is actually the throat. Okay. So here they meet, you see here, the bright point, okay. Wait, let me pick up the pen. Yeah, this one is for water wave. Okay. So here you can see this is the, okay, so this is the crest, right? Okay, the bright one is the crest. Okay, you already know that then when the wave produce, okay, so here they will make the bright one, and this one should be the dark one. Okay, the dark line. So here you can see the bright meet the bright. So means the crest meet the crest at this part. Okay, so here you can see this is the constructive interference. So the point that I put X here, so this is the constructive. Okay, and this one also is a constructive. Okay, and this one also is the constructive. And remember I said just now about the antinodal line. Okay, the antinodal line. So what is the antinodal line? Antinodal line is the when you connected the line that connected all the antinode, right? So here, this is the constructive, this is the constructive, and this one is also the constructive interference because crest meet crest, okay? So you just connected here. So you connected all the line here. So this is, we call it as the antinodal line. You connect all the constructive, okay, interference, okay, in one line. So this is called as the antinodal line, all right? But for the destructive, okay, it's hard to see Okay, because the amplitude is 0, right? Okay. So this we call it as a constructive interference for water wave, right? So you can see they produce the antinodal line. Okay. So that is for the interference of water. Okay, interference pattern of water which is observed through a stroboscope. Okay, so what is the function of the stroboscope? The stroboscope is actually to freeze the pattern of the water wave. Okay, if not, you can see it keep moving, right? So when it keep moving, it's hard for you, to study, right? To measure the wavelength. Okay, so they use the stroboscope to freeze the pattern of the wave, so it's easy for you to see. Okay, what is actually happened during the interference? It's not just interference, reflection also they can freeze the pattern of the wave. Okay, so here you can see, right? Now this one they use the stroboscope, all right, and you can see there is a line here, right? It's just like a line here. So this one is actually the antinodal line. Okay, the antinodal line. Alright, so that is the antinodal line. Okay, so here what I have to do, you have to mark, okay, on the diagram, okay, the region where the constructive interference occur. So we already learned, okay, so for the constructive, okay, it should be from crest to crest. So it's somewhere here, okay, and here, and here, and here, okay, and another one is here. Okay. So that is the constructive interference. Okay. For destructive, okay, should be here. Okay, where the crest and the trough, okay, they meet with each other. Okay, for this one, the picture is not so clear. So maybe if I draw for you, okay, so let's say we have this is a source A and this is source B. Okay, usually they will use the dotted line as the throw. Okay, while the straight line here, they represent the crest. Okay, so I will just draw, this is, let's say, the throw. Okay, and this one again is a crest. Okay, and this one also is a crest. Okay, and this one is a throw. Okay, and again a crest. Okay, this one is a throw. Okay, and this one is a crest. All right. So it's easy for me. Maybe it's easy for you to see, okay, or to label, or if using this diagram. Okay, for the constructive interference, should be crest to crest. So, yeah, use another pen. Okay, so this one it can be the constructive. This one crest meet crest. And another one for throw meet throw also destructive, right? Sorry, constructive. So this one throw meet, this is for this one, and this one is for this one. So throw meet throw also means constructive. So the blue one is actually represent the constructive. So how about the destructive? So let's say the destructive one, I use the pink one. So this is the throw, right? You see the dotted line here? This is the throw. Okay, this is the throw. And this one is the crest. Okay, at this part. Okay, this is the throw and this is the crest. So what will happen here? So this will cause the destructive. Alright. So whether it's a dotted line meet with the dotted line or the straight line meet the straight line. Okay. That one we call it as the constructive. Why destructive is the dotted line, it meet with the straight line like that. So it will produce the destructive interference because later you need to label it. Okay. This one not so clear. Okay, what happened to the water at the region constructive interference? Okay, so we will move up and down. Okay, because they will move up and down because they have the high amplitude there. Okay, what happened at the region? Okay, at the to the water at the region destructive interference. So the water will be calm. Okay, since the resultant the amplitude the resultant of the amplitude is 0. Okay, so this one that I just mentioned just now. Okay, so for this is A, B, C, and D. A, B, C, and D. So A, B, okay, A, B. This one is a constructive. Okay, A, B, C, and D is actually the A, B, C, and D. This one. Okay, it's represent the constructive. Okay, where the water wave, where the crest meet the crest. Okay, or throw meet the throw. Okay, and this point we call it as the antinode. Ingat, remember constructive interference. Okay, constructive interference is an antinode. Okay, while the node is the destructive. Okay, so the node is a destructive interference. Okay, so antinode where the constructive interference occur, and this is the line. Okay, remember I just draw for you. Okay, in the ripple tank just now. Okay, in the video. Okay, we connected all the antinodes. Okay, while the nodes is where the destructive interference occur. Okay, and we call it as the nodal lines. Okay, where we connected all the destructive. Okay, the destructive interference. Okay, so this one actually I just discussed just now. Okay, so remember the dotted line is the throw and the straight line here is the crest. Okay, so maybe we can try to use this diagram. So this one is actually, okay, let's try for this part. The one that I mark X there. Okay, what is the interference? What type of interference occur at X? Anyone want to try? What happened at the X point? Disruptive. Very good, Xiang Wei. Okay, so here means this is the throw. Remember I said the dotted line is the throw. Okay, while the straight line is the constructive. Okay, so this one will be the destructive interference. Okay, how about this one? Okay, I put the label Y here. What happened at Y? What happened here? Is it constructive or destructive? Yes, very good, Joey. Constructive. Okay, this one throw, mid throw. Okay, what happened here? The one that I make a circle here. This one is constructive or destructive? Okay. So, yeah, still constructive. Okay, because crest meet crest. Alright. Very good. Okay. So they connected all the this constructive, okay, constructive line and make the antinodal line. Okay, this one is a nodal line. Okay. Okay, the next one is if they say they give you a question. This is for the calculation. So what is a lambda? Okay, lambda is the wavelength. Okay, so let me. Okay, so the lambda is the wavelength. Okay, what is A? A is the distance between two coherent sources. Okay, so this one we call it as A. Alright, so the distance between two coherent sources. Okay, if let's say we use a water wave, means the distance between the two dipole that produce the wave. Okay, so this is A. Okay, and D is the source. Okay, the distance between the source with the X. Okay, where you measure the X. So this is D. Okay, and X is the distance between two successive antinodal line or nodal line. So let's say it means two successive antinodal line mean two successive constructive interference. So let's say for this one, we know this one is a nodal line, right? This is destructive. Okay, this is a nodal line. So means X is from the nodal line here to another here. Okay, to another one, to the next one. Okay, the adjacent. So here we call it as 1x. Or let's say if you take for constructive interference. So this is the constructive interference. Okay, so means from here to here. Okay, to another one. Okay, two successive destructive interference. So from here to here we call it as another x. Okay, and this one also is actually x. Okay. This one from this one to this one also another 1x, or from this one to this one also we call it x. Okay, so you make sure if you want to take x, it must be the same interference, means must be from constructive to constructive. Okay, or you want to take from destructive, so you must take from destructive to destructive. Okay, so that is x. Okay, A is the distance of two sources. Okay, D is actually the distance between two sources, and where you measure the x here. Let's say you measure the x is here. So means the D is from here, the source, until where you want to measure the x. Okay. And x is from the constructive to constructive or destructive to destructive. Okay. Antinode is the constructive, node is the destructive. Okay, so later we will answer about the calculation question. So this is actually the superposition. Okay, so A plus A, you got 2A. Then after that, this one we continue move to the left, and this one we continue move to the right. Okay, so if you have A and 2A, you will get 3A. Okay, so this 2A we continue move to the left. Okay, and the A will continue move to the right. Okay, and this one is 0. Okay, factor affecting the interference pattern. Okay, so this one you just need to use the formula. So it means it depends on the wavelength. Okay, and also it depends on the distance of the A here. Okay, the distance of the source. Okay, of the wavelength. Okay, and also D. D is actually the distance from the source to the where you measure the x. Right, so this is the formula. Okay, so for this one, I just skip this one. This is just a question. I hope you already go and take your notes, okay, for chapter 4 until 6, and also another one, the module. Okay, the module we use after we finish the syllabus. Okay, so I will stop until here first. So for interference of light, we continue on next lesson. So I hope maybe we can use the class point, because it's not as hard for you to get, for me to get the response from you. It's not only that certain people they answer, another one just keep quiet like that. Okay, so for interference of light, we continue on next week. All right, and for Thursday, continue for the presentation. Okay, so I will stop until here. So for the exercise, I will give in the quizzes, okay, for interference. So I hope you can try to answer. All right, so thank you, class. Okay, so take care, everyone. Okay, stay safe. Okay, bye.
Nak mula.